Hey, so today we're going to write a vocal range detector. So we kind of already got into this a bit in the last video where we built a version of Flappy Bird called Singing Bird. But I really want to drill into making a visual understanding of how we get a user's vocal range. And so that's what I'm going to do today in Pygame. So there's two main focuses in this kind of tutorial and video. The first is we're going to start building a library for manipulating and working with audio input. So we have this voice controller.py, and in here I'm starting to build out what we could use eventually as a separate video game input for audio in general, and it could work with guitars, keyboards, voice, everything. So we're starting that now, and then at the same time we're building these kind of smaller, more understandable sketch applications, if you will. And so that's what this established range is. So let's just run it and see how it works. So if I do Python 3 established range, you're going to see a list of all my devices. So let's do dash input 6, because that's my snowball. It's my little mic you can't see probably. And so if I sing a low note, low, so I'm not a trained singer at all, but you can see how the range detector works. So we get the lowest note first, and then we get the highest note second. Alright, so let's jump into the code. If I hit Q, I can exit. So, like I said, we have these two files here, and the first is the voice controller, and so this is where all the logic is for taking the voice from a microphone and converting it into a frequency using pitch detection and audio, and then spinning it back out as a musical note and a set of cents of deviation for that musical note. And so as we said in the last video, a cent is 1/100th of a half step. Go back and watch the last video if you don't know what a half step is. I kind of go into it more. Same thing with the site. So basically we create a cue with that pitch detection, and we pass that cue into the other established range program. So we have this get current note, and one thing I want to call out here is I've created two things in my function. I've added two key name variables, and I've set them equal to something. So at this equal, I'm setting a default value if this function is called without parameters. So I'm setting the volume threshold to be 0.01 and the printout to be false. So this means that if you just call this function, you can call it without any parameters, and there won't be an error in running the program. It will also default to setting printout to be false. So when we get into the code, we'll see that printout equals false will pass everything onto this queue object we create up here that we can import into our game. So get current note also has this little comment here. So you see 3 quotes, and then I describe it. That is part of having it as a library. So if we import this in IPython, let's do that. Docstring is going to give us some help when we open it up in IPython. So if we open up IPython, let's try it with another library. I don't think it's going to work for this library. So let's do IPython 3, and let's do from numpy, well, let's do import numpy as np. Alright, and so I'm in the IPython shell, and the IPython shell is a really great program that not a lot of Python programs use enough. So we have np now, and I can press tab, right, and I get a bunch of functions that are inside of that np object. So if I do abs and I do question mark, what I get back is the description of how you use this. And so it says call signature and then docstring. So what this is right here is a docstring for Python. So if we were to load this library into Python, it would tell us exactly what it expected and what you could pass to it as default notes. It's really something nice to do as you start building out libraries. Alright, let's move on. So we get the current pitch, and we set it to be a Music21 pitch.pitch. So Music21 is great. It has the ability to take in a frequency on one of these pitches and return out the closest note to that frequency along with the deviation in cents from that ideal note that it should be. All right, so then just as we did with the video synthesizer and the Singy Bird, we take in this stream of data inputs, throw it into our pitch detection, get a pitch frequency, and then we check the volume here. And so checking this volume is going to make sure that background noise in your microphone doesn't try to get detected as a pitch. So then we check this volume threshold and make sure the volume is above that threshold, and then we check and see, hey, is print out enabled right now? If so, just print out the current pitch. Don't put it on that cue. Otherwise, let's set that current variable and then pass it to the cue so that we can read it in the other program. So in established range, which again is that visual Pygame program that we saw, there's just a few very simple things. This is a much easier to read program than the Singy Bird in general. So the main things to note here is we create a screen that's the same size as that Singy Bird. I want to do a whole integrated video game in this series of videos and posts. So we're going to do that, and this is the screen where we'll get our singer's vocal range. So you'll see that I have a screen set up to the same size. I set the display to the same mode, and then I import these title fonts. So these fonts I've included, these are both Google fonts. It's Bungee Regular, and it's in the assets directory of this program. And then I set it to be rendered into a little box. That's what this render does. And then I also do another font for rendering out the note. I create a thread to use that get current note, and then I start it before we jump into our Pygame loop, and then we create a low note variable to be set, and then a high note variable to be set, and then we set whether or not we have a low, whether or not we have a high. Well, actually, this should probably be false. All right, and then we check to see how long we should hold this note to be able to say to our user, yes, you are capable of holding this note at this pitch. And then we keep track of how many samples they've held that note for. And then we keep track of what the current string name of that note is. Finally, we have a cent tolerance. So again, a cent is 1/100th of a half step. So in order to have a perfect vocal note, you're going to have a little bit of fluctuation in there. So got to give your user a little bit of a break. If you're using something like a synthesizer in your input for your game, maybe not. All right, so then we just have a pretty straightforward Pygame event loop. So we check to make sure that the user isn't trying to quit. We check to see if they press the Q button. If they do, set this running variable to be false, and then we can exit. The first thing we do is fill the screen with black, and then we draw this set of lines to show on a line visual with a circle how close or far away they are from the perfect pitch for that note. And so first we draw these two lines, these two vertical lines, and then the horizontal line going across the screen. And then we read from that cue. And then we say, hey, if you're within this 15-cent threshold, then you're in the green. And you know, we could actually change this to be what we set up here, our cent tolerance. So let's do that now. Cent tolerance. Okay. So then we're saying if you're in the cent tolerance, we'll draw a green circle for you. And we can actually, I would like this to be bigger. Let's set it to be bigger. Just so that you kind of get that more, you know, impact. It's all very goofy, ugly kind of graphics for now. And then we render out the name of the note, right? Draw the circle on that line graph, you know, because you can be under in cents or over in cents. Cents can be a negative number. So we set that on a number line. And we multiply it by 2 just to give it a little bit more magnitude. The line isn't really drawn to scale. I didn't bother to draw it to scale because you're going to get a visual impact anyways. All right. And then we render out the note that you're closest to. And then we just keep track of the note you've held. So if your note that you're holding now is the same as the last time we went through this loop, we're going to increment it. And then we're going to check, hey, have you been holding this for the same hold note length of, have you been holding this for the same note length that we set in note hold length? And then if you have, first check if we have low, and then if we don't, sorry, then we set the low note, set it to be the held currently, and then we set have low to be true, and then we change what we're drawing in that title. So instead of saying sing a low note, it now says sing a high note. All right. If you already have that low, though, we're going to need to check, and the first thing we want to do is check that the note held currently for that duration is actually higher than the low note. And so that's what this first if statement does. And one thing to know, I know I've probably said this before, but this -1 checks for the last character on a string. That's always the last character in a Python list. So that's a little shortcut here. So what we're saying is check that last digit on that string of that note and then convert it into an integer so we can compare if it's less than the other one. And then we say, so if the currently held note isn't already set to a high note, let's set that. And then we set the perfect with the, we set the title text to be the perfect, and then we set the title current to be the range that our user has for their vocal range. And of course, if we're running through the loop for the first time or the user's not holding the perfect note, we need to set the currently held note to be whatever note they're holding now and set the note hold back to 0. Finally, we just draw these texts onto the screen and then flip the display, and then with this clock.tick say that we're limiting ourselves to 30 frames per second. So let's run that one more time. Let's exit out of Python, and then let's do Python 3, and then it is establish range.py, and then we do dash input, and I do my blue snowball mic, which you can't see on camera, and then I'll just do low high. All right, there you go. I've had a little bit of practice with this, but you can see how the visual effect works with it. Cool. Thanks. Subscribe if you want to see the rest of this. We're going to build a full game using singing and using vocals. And if you want to see how to do that, just subscribe and watch it in general. All right. Thanks. Bye.